Hi all, this is Harini. Welcome back to our channel Code with Harini. Today we are going to solve August day 18th challenge 24 game. So basically we'll be getting an integer array cards of length 4 and you have 4 cards, each contain number in the range 1 to 9. So we should arrange the numbers on these cards in a mathematical expression using the operator plus, minus, multiplication and division and the parenthesis to get the value 24. So we have restricted to some rules, which is the division operator represents a real division, not integer division, which means so if 4 by 11 means it will come under 3 point something, right? So we should take 3 point. It's not like you should round off or something to 12. Okay, 4 here. So 4 here, if you also see here, 4 divided by 1 minus 2 minus 1 by 3. Okay, so 4 divided by minus 1 by 3. So in turn 3 will go up, so we'll be getting answer as a minus 12. So here they have given it as a wrong, but answer will be minus 12 for this case. So here every operation done in is between two numbers and you should not use minus as a unary operator. So which means if the given number is 1, you can't add that minus in front. So we can't concatenate numbers as well together. So if they are given 12, 1, 2, 1, 2, you can't concatenate as a 12 plus 12, 24. That is also not valid. So we should have these things in consideration when we are solving the question. So we should return true if we get a such expression that evaluates to 24. So here they have given example 4187. So here 8 minus 4 is 4 multiplied by 7 minus 1 6. So 4 6 are 24. So here whatever you do 1 plus 2 3 2 minus 1 whatever you do, we are not getting a expression that evaluates to 24. So let's take a look at the example. This is the example 4187. So what initially we have to do, we have to check all the expressions with all the numbers. So 4 plus 1, 4 plus 8, 4 plus 7. So 4 minus 8. And once you've done the plus, the next also will be the same, plus minus multiply division, plus minus multiply division, like this. You have to try with all the possibilities to get whether any numbers satisfies or evaluates to 24. So that's the only way that we can do. So once that evaluates to 24, you don't need to check further. We just, because we have to return true whether any number that evaluates to 24. So what initially, here I have shown one example how we'll be doing this. So initially we'll be running through two loops. Okay, so this will contain I and it will check with j as 1 8 and 7. So once these two numbers we have taken into consideration with that result, so now instead of adding that into a bracket, we are storing that result into the another array and we are passing for the next. Now this will treat it as the same for how we have treated as a first condition for the first loop. So what here it will do, first initially we'll be doing 4 plus 1. Okay, 4 minus 1. So these are the different operations that we'll be performing. Okay, 4 plus 1, 4 minus 1. So plus will be the same no matter what, x plus y or y plus x, but x minus y minus x won't be the same, right? So in that case that's why we are doing nums of I minus x, so nums of I minus nums of j. The same way here j minus I we are doing. Multiplication is also same, x y x will give us the same answer. So that's why we are doing. So once we couldn't find any of these resultant answer that evaluates to 25, then we will be dividing the I by j based on the condition anything contributes to the value 0. Okay, because it's all when you are multiplying or doing minus, so that might be the possibility when you are dividing, it will have a floating point 0.25 or 0.0001. So which in turns when you are dividing it will go to 1 by 0 infinity case, right? So to avoid that, we'll be doing the division once we have run through all this addition, subtraction and multiplication. So here if you see, initially 4 plus 1 we have taken, so answer is 5. Since it is a parenthesis, I am adding at the end, so it should not have 8 plus again. Okay, because we will be taking any two numbers into our consideration, right? So now this is, we have computed the result that I am adding at the last. Now 8, what are the remaining 4? If you take 4 1, I will have 8 7. So 8 7 is, now again you will do addition. So 8 plus 7 is 15. 8 minus 7 is 1. 7 minus 8 is minus 1. 8 7 is 56. So all this again we are adding it to our new nums with the existing. So next again when you are calling the next recursive call, if you see here, we'll be having 5 and 1. Again do plus 5 plus 15 is 20. 15, 5 minus 15 is minus 10. 15 minus 5 is plus 10. 5 15 5s are 75. So in this, when once we have reached this limit, okay, now the array is becomes 1. Now we have to check whether this is become 24. Any value becomes 24? No. So if not, then when it traversing back, we'll be checking 5 divided by 15, which will give 1 by 3, contributes to 0.9 something, right? So then it will, then with 0.9 also, with 0.9 again it will call another loop and it will check, okay, is it evaluates 24? No. So now it will come 15 by 5 will gives us 3. So with this 3 it will call the next recursive call and it will check whether it contributes to 24. No. So in this case, here if you see what all we checked, so initially 4 plus 1 plus 8 plus 7, right? We will have, so in total of this we have checked, um, 4 plus 1 plus we have checked, right? 4 plus 1 plus 8 plus 7, then we have checked 4 plus 1. So here 5 minus 15 we are doing, right? So 8 plus 7, so we have checked 4 plus 1, multiplication by 8 plus 7, 8 plus 7 minus 4 plus 1, also we have checked 8 plus 7 divided by 4 plus 1, and we have checked 4 plus 1 divided by 8 plus 7. So none of this expression have contributed to 24. So like this we will be keep on checking all the n square array. So there will be possibilities when you are taking 4 1, next 4 8 you will be taking next 4 7. So again for 1 we will be checking, next when 1 comes we'll be checking 4, we'll be checking 8, we'll be checking 7. So when 4 comes, so again 8 comes, we'll be checking 1 4 7. So like this we'll be trying out all the n square possibilities. Got it? So that each n square will go to n factorial. So each n square will go to n factorial. So here if you see 4 will goes to 3, 3 will goes to 2, 2 will goes to 1. So again it will keep on traversing through all the operations, right, which is basically 4. So here, so if you, now we are just, so now you hope you understood how we'll be traversing through all the operation plus minus and multiplication. So now if you see this will be the resultant one of the resultant ways that we will be traversing in the recursive approach. So here if you see here 8 minus 4, if you initially would have take 8, so 8 will go 1 4 7, right? So here this 8 in that will be traversing 8 plus 4, 8 minus 4, 4 minus 8, 4 4 8. So all this, but among this 4, our 8 minus 4 is giving us the solution. So here if you see 8 minus 4, if you take, so we'll be ignoring 8 and 4 because we already taken. So 1 7 will be in the next array with the resultant as a 4. So it is 1 7 will be again going to the next recursive approach with 1 plus 7, 1 minus 7, 7 minus 1, 1 7. So here our answer will be lies in 7 minus 1, so 6 4. So 6 4 also in turn will go 6 plus 4, 6 minus 4, 4 minus 6 and 6 4. So here if you see we'll be getting 6 plus 4 as a 20, 2 minus 2, here we are getting 24. So when these all goes, resultant 1 will not equals to 24, so we will be getting written, then we'll be doing 6 divided by 4. Okay, so why initially we'll be traversing all this solve. Once we didn't get any of this, then so which means okay, we have checked addition, subtraction and multiplication. Among this we didn't find the solution. Now let's go to the division 6 by 4 or 4 by 6, but in our case we have got 24 in multiplication, so we don't need to check division. So from here it will return true, then it will return true from the main loop, and now it will exit from the recursion. So yeah, so here it gives us 6 4, 6 4 24. So like this we will be figuring out trying out all the possibilities to get the solution. Now we know we have to check where first we have to take any two integers and we have to do addition, subtraction, multiplication. With that answer, what are the remaining left over in the array, will be calling the next recursive approach and will be performing the same operation until we are reaching the single length of nums. Okay, once we are having single nums of length of nums equal to 1, we know okay, now we'll be checking whether this value is equal to 24 or not. If not, we'll be continuing the further recursion. So now if you see here with this, so this is the approach that we'll be using to solve the solution. So it's exact same what we have discussed. So we'll be converting all the card values to a float, because when you are doing division, right, it will be float point value. So we'll be initially converting all this to a float and we are sending it to the array. So initially we'll be taking ij, two nums, and we'll be performing whatever the remaining nums will be, whatever the nums that is not equal to ing. For example, we have taken 4 1 8 7. So initially we have taken 4 1 into consideration. What is left? 8 7. So that will be the remaining nums. That in that whatever the resultant comes with 4 plus 1 or 4 minus 1, 1 minus 4 or 4 1 multiplied by 4, all these things will be adding it to the resultant remaining nums and will be calling the second recursive approach. Got it? So once we have got any result from the remaining recursive approach, so here we are checking, we are since it will be a floating number, right, sometimes it will be 23.35 something like that if comes. Okay, so when you are doing minus 24, maybe it might be if it is less than that ignorance value 0 0 0, so 0 1, so this is 1 e to the power of minus. If you can ignore this minimal, also that is also equal to 24 only, right? So for example, if you take 23.55555, so this also contributes to 24. So that's why we are checking if that absolute, when you are subtracting, that is less than this 0.001, you can still consider it as a 24 because it's all floating point value. So that's why we are checking here. So the same will be checking I also should not be equal to j. If not equal to j, then you will be considering the two nums, addition, subtraction, and multiplication. Once we have find out the answer in this itself, we'll be returning true. If not, so we'll be checking whether nums of j is greater than. So we should not do 1 by infinity, right? So that's why. So 1 by 0 will contribute to infinity. So to avoid that, so we'll be checking, okay, nums of I minus divided by nums of j. If it's greater than, we'll be adding that to the remaining nums and we'll be calling for further recursion the same. I by j will give different answer, j by I will give different answer. So that's why we have two conditions. So if any of this have contribute to the 24, will be returning true from here and it will return true. If not, it will return false. I hope this makes sense. So the time complexity for this is, so here we'll be calling, if you see here it is n square nums will be traversing, right? So which is order of n square. So each n, it's not like it will be always 4, right? So because we'll be keep on traversing 4 2 3 3 2 2 2 2 1, so which will be n factorial. So we can't blindly predict its n square, so it is n factorial square. So here it is n factorial square. So then the space complexity for this will be, here we will be initially storing, will be passing order of 4. So order of 4, then we are passing, so which will be storing again 3 2 1 array, which is constant, it's not will be storing order of n every time. So for here we'll be storing order of 3, then will be plus order of 2 plus order. So n factorial will be storing to the max, but since it's a constant, so we can ignore that. So in here it might, there might be possibility we'll be having stack space of order of n as which we are passing, because it's a recursion, right? So obviously we'll have the stack space. Yeah, I hope this makes sense. Let me know if you guys have any questions in the comments or any further explanation needed or something I could have explained better. If you do like my video, please do like, share and subscribe to your friends. Yep. Thanks for watching.